I hope you all are fine. So today I come up again another video which is also related Kubernetes, and there is much theoretical things we will discuss today. So where we have some more major discussion about the networking in the Kubernetes and how your ports are communicating to each other. So major parts of theoretical, so you have to just stay with me. So some main components and main things will be discussed here in terms of networking in Kubernetes. So today topic about underlay network. What is the underlay network? And another one is the overlay. So most of the things are related to this thing, and we will discuss some other services which we are using creating these overlays network and underlays network. So before moving into this topic, let me give you some more details or some basic concepts about this thing. So what happened when we let's suppose we have a node, and we in this node we have a Docker engine, and Docker engine has install or launch a container. Let's suppose this container which is launched by Docker engine, or a pod or Kubernetes launch this thing. Okay, so it's up to you, so you can use it. So let I have to assume that this is my pod, and its pod is launching by the Docker engine, because Kubernetes, as you know, the Kubernetes is using behind the scene Docker engine, and Docker engine will launch a container. So what happened? We have a physical network here, which is name is ETH0, and the things which is in container is also has a physical network card, which is also called a ETH0, but this is not the actual Ethernet card. It's somehow a virtual Ethernet, because as you know, if I can go on my this node, and let me show you my cards here. So in this my master node, I have just this single interface which is the related to the physical Ethernet card. So this is my IP of my node, and rest of others we will discuss, and what is this thing and all these things and how they are configured and these to each other. So somehow this is a virtual card, but for the container, it's look like a physical card. For physical, for ether container, it's a physical card, but for the host, it's a virtual card. So we can say it's a vETH card for the host of this machine, where we have the Docker engine and we have launched the containers. So how the communication is possible in this? In this we have means this is my host, and in this host we have a Docker engine, and in Docker engine what happened, or you can say it's our Kubernetes master node or worker node, you can say. Once is launch this thing, so they launch means when you are creating this master or worker node, so they create a switch here inside the your machine, which is a called a virtual switch or virtual router, you can say it, but mostly we are using as a switch here. So how the communication is possible when multiple containers are launching? Have you seen that? If I have container 1, container 2, container 3, and they all communicating each other, so how it's possible? So this is possible with the help of this switch, and this switch name is normally CNI 01. It's a by default name of the switch when you configure or launch your masters or node or worker nodes. So Once my container 1 is launched, so it creates a connection with this switch, and this switch has some virtual ETH0, that is called a virtual card for the host, but for this it's a physical card. So once second port will be launched, so it also create a link between this switch and the container. And as you know, this is one box like that one, so it's like a LAN network is created here, so they can ping each other, they can reach out each other with the help of some networking concept, and some networking parts will be involved like the IP network subnets like that ones, and DHCPs also. So the DHCP is also done or given to the container via with the help of network. And this, how can we this use it? It's it's something, and this switch is sometimes called a bridge. Sorry, bridge network. So we created a bridge between our host and the container. So how can we check how many bridges are network in my or how many networks I have in my worker node or master node? So there is or it's also a called a SDN. So you can create a software defined networking. So you can create multiples network in the in your master node or worker node, is it's up to you. So we have just by default it's created a CNI bridge, that is also called a bridge network. So it's created when you are doing installing the master and worker node in the Kubernetes server. So let me show you about this thing. So how can I check the things are, and let me one more thing I have to clear it here. Once the network is the container is launched, once your container is launched, your one Ethernet card has been launched to the with the. So what happened? This is called a bridge bridge network. We can say it. It's done by with the help of SDN, because we have multiple softwares are available to create the bridges, switches, routers. So in by default, it's a switch in created when you are going to create this thing. So let me show you in my Kubernetes cluster. So there are multiples of Ethernet cards available. So let me IP ADR. So here is my one physical card, which is physically connected with my Ethernet, and rest of others are some others things are going on in this machine. So how can we check in Kubernetes how many bridges, switches are available in the in my worker node or my in my master node? So how can we check? One of the command that is called a bridge CTL command, which is you can check it if you one of the bridge CTL command, which is you can install it bridge utilities in your CentOS or Ubuntu machine. So then this command will be available in your machine. So let's see how many switches we have in my master node. So bridge CTL show. So there is one switch, one bridge name, that is called a switch, that is name is the CNI0, and it has interfaces which is attached with this one. So if you don't have any, let me move on my worker nodes and running my same command to here. So here also I have, so one of another interface is attached. Let's move on to the node 3. So purpose is showing to this thing to means uh, things need to be more clear about the concepts on the Kubernetes networking. So there are just with these thing, and with is means some ports are running and they are connected with my node 3 with this switch, and this switch is connected with my worker node physical ethernets. So this is how some networking done in the Kubernetes. So some terminologies which we have discussed here. One is the veth. What is the veth? And veth means virtual network card, which is attached with your host interface. So whenever the pod is launched, so one first of all it's create a Ethernet, and Ethernet is connected to your CNI, and then CNI create a link with your host and attach with this name veth. But when you are move into the port, you will see the name of the Ethernet is the E0. So containers assume that I have the physical Ethernets, but it's not like that one. So let me show you here. So let's create a deployment. So I have already, so I have created this deployment, and let's see it's running or not. So it's running. So let's see where it's running this port. So -o white. So once it's done, so it says on port 3 it's I have launched this port. So let's move on to the port 3. So before that we have just two Ethernets are connected with this switch. Okay, so let's see is any other interface have been attached with this one or not. So it's attached. It means we each one new have come up, which is the name of this one, and it's connected to the CNI, and CNI connected to my node Ethernet interface. So that's how it's working. So in attached interface is like that one. So let me show you here as well. So one of the Ethernet will be come up this, I think this 761. Okay, so this is the same Ethernet attached with this ID and with this interface, something like that, and has some MAC addresses as well. So this is how some linkage between the machines and in terms of networking concept. So let's move on to the over underlay network. What is that one? So let me explain you here what is the meaning by underlay network. Let's suppose I have one PC and two PCs, one is here, and I have some OS on it, and some OS has means I have a physical Ethernet which is ETH0, and it has also a ETH0. So they have physical connectivity between them. I have connected these two wires and connected with these two PCs. Somehow in switches and routers are between them, but we are assuming that we are connected with this thing directly to each other. So this is concept is called underlay network. So you have connected your machines directly to the between each other with each other, not between is with each other. So this concept is called underlay network. So there is no somehow more deep dive into in this underlay network. So if we can say this, so the challenge is here about the connection between two OS, which is with the help of some physical connectivity we have required here, and we have connected these two machines with the help of physicals connect given to physical connectivity, and this scenario is called underlay network. So, but the challenge is where we have facing these challenges. Let's suppose we have a uh, one worker node, which is worker node 1. We have the Docker engine here, and we have some switches are here connected CNI 0, and we have launched some container here, and they have made the connectivity between them. So another we have another worker node 2. We have Docker engine is running, and then we have a CNI already 0 with the name of this one, and we have created a container number 2 here. So there are multiple container when so the good thing is in the Docker engine is that whenever you launching multiple container in it, so they can communicate each other because they are in some isolation mode, and they are connected with very privately to each other, and they are in isolated, so they cannot connect or they cannot go outside the this and get the IP of this or communicate this thing too. So the challenge is this: how we can make communication this thing. Let's suppose an example here. So what will be the example? The example is look like that. Let's suppose I have a one worker node. In one worker node, I have the Docker engine. In Docker engine, once is created the CNI 0, and I have launched a container which is container 1, and it's let's suppose it's a WordPress container. And one another node I have worker node another which is have the Docker engine, and they have also a CNI 0, and my container 2 will be launched here with the let's suppose it's my DB. So the challenge is here, if my client want to connect my application. So let's suppose I have the services here. Let's see, I have the services here, and it's now go into the services, and I have exposed it. Let's suppose, and they connect to my this host IP. Once it's connected, and so he can get the data only the front end data, which is my WordPress, but it's not connected to my DB. So as you know that the whenever we launch the WordPress, it's required a DB connection. So but now we don't have any communication between these two worker nodes. So how can my DB will be connected to my worker node? So how the communication will be possible to these between these two things? So for that we have come up again another solution, which let me know you what is that one. So let's suppose again I have the Docker engine, we have the CNI. So we have created a WordPress, and we have some Ethernet card which is 0, and we have some other networker node 2. We have the Docker engine here as well. We have the CNI 0. We have created one another container which is the my DB container. So it's the same one, and we have some physical card here which is the ETH 0, or it's maybe in so it's depend upon your worker node. It's you are inside your network or outside your network or outside your boundary of your data center. So it's depend upon you. So before that, app will be launched this one, and we have also a app will be deploy on this one. So now we have created a one and other container here, which is let's suppose 20, and they are also connected to this one. We have connect another or deploy another resource or another connector which is connected to my this CNI. Once the CNI is connected to my this container, and my this container is also connected to CNI, so my C1 can connect to my C20, and my C2 is connected to my C21, let's suppose. Okay, and somehow we have connected directly, or we can create some method, use some program which is direct, can make connectivity between your C20 to their physical interface. A C20 will be connected to your this one. So my C20 will be connected to my ETH0 and my ETH0. So now the packet will be flow like that one. And let's suppose it has the network of 10.0.1.2 IP, and it has a 10.0.2.2 IP, and this is the same IP will be come up, and 10.0.1.3, and this will be like that one, 10.0.2.3. So these are the IPs, and they are can communicate each other because it's like a LAN. Okay, so they can communicate each other. It's very simple one. So what we can do here, so we can make some intelligence apply on this container with the help of some program. And what will be the program will do? So it will be done, or the work of the C20 container is that it says whenever the packet will come to you and wants to go outside the boundary of this lane, so you have to forward this query on the ETH0. So we have something, route table will be created here. We will create a route table. So here will be the route table will be created. We have also created a route table here as well. So this is done by automatically. There is no big need to be done by this, because the things which we are using here, it will be done automatically. So all the things are come up here, and then it will be goes on to the this boundary attach, and this packet will be go on to this one, and this will be connected to your this route container, and again the reverse will be done like this, and packet will go on this, and it will be on your worker node 1, and then the packet will goes here, and packet will be move on to the C1. So this is the thing, or this is a thing, or to where we can align, or we can arrange our data, means with the help of route table. Without this, we cannot achieve route table. If the route is not available on this program, so we cannot communicate with our another things. So there is something which is done by this program, and this program. We have to launch this thing in both worker nodes. We have to. So it's something like that. We can say it. We can say it. It's something like that. We have connectivity directly. Although it's going on ETH1, and then go on this path, and then go to this one. So between these things, we can say it. We have before going to this. Let me tell you about one thing more here. We have created this path. Let me drive this thing from here. We have created this path, and then it goes on this, and move on to this, and then again move into this. Okay, so somehow this path and these things, we can say this is like that one. So this is called a overlay network. We are going overlay network. We are going over the internet, or over the outside the box, with the help of some other resource. but we are using that one. So this concept is called overlay on overlay network. So now one more thing here, we have connected some, you can say it's a directly connecting or connection between them. We have somehow we have created this direct connection to them. Let's so it's something like tunnel. In tunnel we have multiple tunnel, you can say it's like a GRE tunnel we have, and one more tunnel is mostly is called VX lane. So this is a concept of also a VX lane in the overlay network. What is this one? Overlay network means we have two PCs and they have some container running on it inside. So this is A, this is B, CNI, the container 2, container 1, CNI, Docker engine we have. But they are in one box. They are in the same VLAN and we have connection between them, connecting between them with the help of somehow using tunneling concept or overlay concept. And these things are connected a VX lane. We have extended the lane with the help of somehow tunneling concept come up. So we have been sharing our some networking our network part to this machine and they sharing their network part to us. So we know each other networks, means we have discussed that there is a network defined. Here we are using /24 and here in B we are using 2.0/24. So they shared our network to us and we shared our network to this. So this is somehow in one box we are using a same lane and same connection between them with the help of somehow tunneling concept come up and connect it to each other, and this is called a VX lane. So that's how a overlay network have been done in tunneling and some concepts which I have discussed with you. And one more thing, so route table, how the things will be finalized. Let me just finalize this thing, how the things will be go on. It is something, let me explain it here. Yeah, so my C1 know my C20, then C20 know the ETH0, the ETH0 know somehow ETH2 and then ETH21, and then it's connected to my C2. So this is how the things are done. And this program, which is very important, we are running here, has some more feature on it. So multiple programs available, we can use it here. Right now I'm using a funnel concept, funnel networking here. They are managing my DHCP as well as my gateway or router of my ports, act as a router, port, switch, DHCP, like that one. And also maintaining the route table, because if C1 wants to go 10.0.2.2, let's suppose, and because when what happened in the C20 says I know because of this, and because how this know it, because of this. So 10.0.2.0, I know you have to go on this path. Which path? You this path. You have to move on this line, or you have to this move all your traffic on this path, and then you can achieve the thing which you want to be achieved. So here is the same one, route table will be maintained of 10.0.1.0. so they know where is the one, because we have a one network, one subnet network is here which is running, and two network subnet network is running here on this side B on this worker node 2. So somehow this is what is funnel here. Funnel is a program which manage to your DHCP of your network or ports. Whenever the ports is running, the DHCP's IPs will be given to this program, and also maintaining your gateway or or your router as well. One more thing, I have to explain it here. A kube proxy, which we have already discussed. So let me show you with a little bit diagram here. So what is that one? Let's see. I have a client, and client wants to connect my container 1, and we have the container B, container 2, and client wants to connect my container 2, and we have some other container which is 20. So first of all, my client will lend it to my C20, and C20 will route this thing to this one, and it zero this one, and then go on to my C21 and my container 2. So this concept is also called a kube proxy concept. So all the worker nodes, all the things which are not directly or getting the directly data to the client, they also comes onto your required machine, and that required machine will proxy your data to proxy your request on the required server, and then go on that server and get the data, fetch the data, and give it to the client. So this is one of the kube proxy examples here also come up in this lecture. So I think I have done the things here completed for the overlay, VXLAN, GRE. We have some discuss about CNI, how the containers are connected to each other, how they route the traffics, and what is the overlay network, what is the underlay, what is the tunnel, what are the route tables, how the kube proxy works in this scenario. So this is how we can check it. So let's move on to the let me show you how the funnel is working or how the funnel is configured. So it's very easy to means you can just google some commands, will be you can get it from the Kubernetes official website to install the funnel network. I have already configured, so let me show you. So we can say, we can see here that there are three funnel network. Why three funnel network is here? Get why three funnel network? Get nodes, because I have running my cluster kubectl on three nodes. So in each node I have my network. So let me explain you here. So I have master, and I have two worker node. So in each network, in each node, I have run a funnel pod, funnel pod, and they are all connected to each other. They know the route of this one, they know the route of this, he know the router of this, he know the route of this. So they are directly connected to each other. Okay, so there is no so that's why we have launched three ports of the funnel in the Kubernetes cluster. So that's all I think. And the thing which you have to check, you can see war funnel thing one, run funnel. var run funnel network, sorry, funnel network and subnet dot. You can see the, let me show you here. That is called a network network, and its subnet MTU size. This, whenever the pod is launched, the pod will be get the IP from this network. Okay, it's depend upon its whether it's launching in your A node or node 1, node 2, node 3. So they have some different subnets as well. So IP will be come up on this range, So how the things means, how can I check the my network funnel is a VXLAN? So we have one command to get config map minus n cube system. So we have a kernel configuration file is here. Config map we will talk about in my upcoming lecture. So let me just edit one, edit config map, then config map name is this, and then minus n, then cube system. So we will not change anything, just show you the things are the version of visit, the type is funnel, the port map is here, and we have some others parameter. I hope so. We have this thing, the network, and the type is VXLAN, and the port which are the services running of the panel is this, and the network which are we are using it here. So you can change it as per your demand, as per your requirement. So we have multiple things are on it. So that's all guys. I hope you like this video. However, it's more not too much practical, but have some more concept, more knowledge about. I hope you understand the concept of overlay, underlay, and the somehow the ports which are running in each number of worker nodes, why we are using this funnel, and what we will talk about the weave network as well in my upcoming class. So we are working on it. However, I have defined very well. If you face any problem, anything, and you have any confusion in this lecture, so please let me know. Thank you guys. Thank you guys watching this video. Bye.